Okay, hi and welcome to our next session of video notes. This one is what we would like to call is it a function? So let's review from the last video just so we have a concept of what we're trying to decide is a function or not. What we learned in the last video was that a function should be a vending machine, meaning that our buttons, right, should be inputs in terms of an actual function. Inputs meaning we'll learn a little more about it, but x values. And then our snacks, what was in the vending machine, right, are going to be our outputs, which again we'll reaffirm today are y values. Additionally, with that concept of a function, we learned that it could come in four different ways. One, we could learn to come in context. So it could be a problem about Mr. Hallam and having kids added to his class. Or we could make a table of that data, we could graph that data to see it, and then finally there was a rule that seemed to control that data. So that's what we found in the last video. But in the last video we had more than just a function. We also had a relation. So a relation was, if I scoot back over here, was a set of patterns. We could see a set of points, but it didn't function under one of our specific rules. So it was kind of what we said was a bad vending machine, meaning that when we put some buttons in, let me go back over here. If we press some buttons and it was supposed to go to this snack here, but it kicked out something different, we said that was a bad vending machine. So every button should give us exactly the snack that we expect to get out of the vending machine. So today we're going to decide or learn how to decide which of these vending machines or functions or relations are functions, because functions have a very specific rule. So let's just reaffirm some ways that we're going to see these inputs and outputs of the vending machine. So an input then is a lot of times referred to as an independent variable. These are things that are picked or given to you, meaning you'll get a table of values, and these x values will go -1, 0, 1, 2, or you pick those values. Sometimes you just have to pick them because you know, hey, that's where I want it to be. These are always along the x-axis. So these are x values that you'll find along the x-axis. These are the values that we're picking or given or are independent values. Okay, and then most of the time when we deal with these, they're going to be terms of time or distance or money. And right now you're like, why? Well, it's because those things just are. When we look at the outputs, they're called the dependent variable, meaning that they're not in our control. They just come out, right? We have no control over those. So these are the y values that we evaluate for. We don't know what they're going to be. So that's key for them, that they get evaluated for. They're not in control, they just happen. They're y values along the y-axis, and usually these are things that like time versus distance or height or money versus product. So these are the results. So these end up being our labels or situation or context for inputs, and height, products, times, other things that we'll talk about as we go are our outputs. Okay, so now that we understand what things are going into our function and what things are coming out and kind of what they mean in that terms, right? You can see that we can make a table from them if we combine the two, which makes them set of ordered pairs. Here's what we're looking to do today. So a function then, not a relation, is a relation that assigns exactly one output, meaning one snack, right, for each input value or button combination. So what that means is that when I press some buttons, I better get that snack. And it can't give me some different snack. So what that translates to for us in functions, right, is that really there's no x values. If they're repeated, that's usually an indicator that it's not going to be a function, that it's going to be a bad vending machine. So let's see that in action. So far we've looked at it as a vending machine, but now it looks like a bunch of points in set notation. So these little fancy brackets out here mean that this is a group of buttons and snacks that were hit. Let's say it that way. So the first number here, 1, was pressed, and then 2 would be the snack that come out of it. I don't know what 2 is, I don't know what snack it is, but that doesn't matter anymore. Now we said we pressed 1, we're getting 2 out. That's our input, and there's our output is 2. So that's fine. That means that I put that in, that's great. What we're looking for then is those repeat values where I press a button, and so in the next combination of buttons and snacks that I see, if I see 1 and it doesn't go to 2, then something's wrong and that's a bad vending machine. So let's check that. 1 goes to 2. All right, we're good. Well, -1, that's a different button, so that's fine. It goes to -2. Well, 2 is a different button as well, and it goes to a different snack, so we're still good. And -2 is a different button again, and it goes to -3. So every button combination went to a very specific snack. Perfectly fine. So this is a function, and every input has one unique output. That's what we could say to kind of describe how that is. So if you jump over to the next one, though, you'll notice that 7 goes to -2. So I press the button 7, I get the snack -2. But look at the next set of numbers. So this is again a set of numbers, right? One set of ordered points, two set of ordered points, 3 and 4. On the second set of ordered points, I press 7, I get 2. But over here, I press 7, I got -2. So this is me saying, hey, I'm going to press 7, I'm going to get a Snickers. And the next time I go in, I'm going to get Cheetos. That makes a bad vending machine. So no, this one would not be a function because sometimes the input 7 gives me 2 and other times it gives me -2. So that's how you determine if a relation is a function. Hopefully that kind of works for you. So here's two more examples. As you can see, I press 1, I get 10. I press 2, I get 20. I press 3, I get 30. I press 4, I get 40. All right, inputs being x values, y's being outputs. And this is just a horizontal table versus a vertical table. Exact same operation, just one sideways. And again, let's check this one. 1 to 10, 2 to 10, 3 to 10, 4 to 10. You're like, oh, wait up, Mr. Hallam. They're all 10. That's okay. It's just a really boring vending machine. So for every button I press, 1, 2, 3, or 4, I'm getting the same snack. I don't know what snack that is, but it's the same snack. So it's just all the spots in the vending machine have the same snack, and that's fine. This is okay. Students will get tricked by this. So they see that we said no repeats of x values, but we didn't say it wasn't a function if the y values or the independent or the dependent variable repeats. That's perfectly fine. All right, so let's move on and answer some more questions here. It says graph the following set of points. So here's a button combination and snack, and there's 4 of them, right? So 4 ordered pairs, and we've plotted those over here, right? Remember, this is the x-coordinate, so I go over 1, and this tells me to go up 2 for the y-coordinate here, so I go over 1, up 2, and that's where I make my point, and then I repeat that for all of them, just to review. So is this function, or is this relation a function? Well, hopefully we can see here that when I press 4, sometimes it goes to 5, and sometimes when I press 4, it goes to 6. So visually, from the last set, we should be able to tell that it's not a function. But look what happens, because the next question says, what do you notice about 4, 5, and 4, 6 on the graph? Look what happens with these points. Notice they're vertical, right? So if they weren't, if this point was over here a little bit, then guess what? It would be a function. But when we plot these points visually, what we're looking for is that if I were to draw a vertical line through them, that would represent an overlap. If I touch more than one point, then we're saying it's not a function. Okay? And let's take that to the next level then, is we're going to have a procedure or a test for all functions, not even ones that are discrete, and we'll talk about that next video, right? Discrete meaning points, but now we're going to talk about functions that include every point, okay? And we're going to call that the vertical line test. So we use this vertical line test to test a function that maybe is a line, right? And we can do it on points as well, but we usually use it for some type of line where we draw vertical lines through it, and if it touches it more than once, then it fails the test, and so it's not a function, it's just a relation. So let's summarize that. Fail the vertical line test, or sometimes noted VLT, right? So to fail the VLT, if it touches more than once, then it's not a function. Now, here's the rule of thumb for this. It needs to pass at every point everywhere to be a function, but only needs to fail once to be a relation. Okay, so it has to continually pass everywhere we can draw a vertical line on the function. But as long as it fails one point, then we know it's not a function anymore. Or not a function, and it is a relation. So let's see if we can determine this. And I've already drawn all the vertical lines on here. So I drew a vertical line here, I drew a line right here, here's this function. Do you need to know that this is a square root function? Absolutely not. You don't need to know anything about it. This test works regardless if you know anything about the function. So I can draw vertical lines anywhere on here, but you'll notice that all they ever do is touch it one time. So this is going to pass the test, which makes it a function. On B here, I only have to draw one line right there, and it touches once, twice, 3 times right there, so it only has to fail once, so it is not a function, it's just a relation. And then you can see this pattern, C, right? I can draw as many vertical lines on C, and notice these arrows extend it forever in both directions. And I can continually draw vertical lines on it, but it's still going to fail everywhere. Or I'm sorry, pass everywhere. So it is a function. All right, D, I only have to draw one line because it touches here and here, so it's not going to be a function. Okay. All right, looking at E, draw a vertical line on our circle. And again, It touches twice, so not a function. So it's not a fun. And then this one here, even though it's what we'd call like a piecewise function, not that you need to know that, it doesn't matter how it looks. I can draw as many lines as I want on there, and it's going to pass them all. So this would be a function. All right, so let's review. So if we go back, we learned that our vending machines, our relations, can be a function if exactly each output has exactly one specific input. Okay, we know that the inputs then are the independent variables, the x coordinates on the horizontal axis. The outputs are the dependent variable, the ones that we evaluate for that aren't chosen for us, they just happen, and they're on the vertical axis. Okay, as a set of points, and we'll learn later that these are discrete, right? A set of points, if that's what our function looks like, it means that when we see an input, that it goes to a different output, and it does it to a different output after that, that means that it's not a function. So no repeat x values, but repeat y values are okay. Okay, and then if we take that a step further, we learn the vertical line test, which says that we can do this on continuous functions. Again, we'll talk about that later, that are lines, and that we just have to draw a line. It has to pass everywhere, and it only has to fail once. All right, good job today. We'll see you in class.